Let's suppose I have a number of people who are about the same skill level, and I am asking them to estimate, for instance, how far away is that object or how tall is that person? And if they're all at the same skill level, then we would expect that some people are going to overestimate and other people are going to underestimate. The overestimators are basically going to be symmetric to the underestimators. And we find that when we're dealing with errors, very often the perception of reality and how it varies or deviates from the real answer, from reality, the target, if you will, tends to be normally distributed. What we've done is we've put together a little visualization for you in this Lines on Clay sheet in Google Sheets that you can click to and, just play around with. We have a large data set, and within that large data set, it is normally distributed. We just designed it to be normally distributed, okay? So the real point here is that in the first bar, you have 30 different categories. So you're creating a histogram with 30 categories and just getting a feel for what that would look like. That's what we have here. And you can change the mean, mu, and you can change the sigma or the standard deviation. So you can make it 12. And then that changes the x-axis values here. It changes this, mu minus 3 sigma or mu minus 2 sigma, but the overall shape remains the same. What happens if you go to 50 bars? Well, if you go to 50 bars, it looks a little smoother, doesn't it? So it's the same underlying data, and it's a big data set, that's important, but instead of 30 categories, I have 50 categories. By the way, what's this thing doing here? This is asking about between questions. So if my mu is set at 80 and my standard deviation or sigma set at 5, and I'm asking, well, what's the probability that my random variable, the thing that I'm interested in, falls between 76 and 84, well, there's a 57.63% chance that that's what's going to happen. And this is a visualization of that. So if I were to change these values, just keep your eye on this bottom right. If I was to turn it, say, into a 70, now we're set at 76%, and that changes the visual. By the way, if you were just kind of interested, what's the likelihood that it would be less than 84? Well, just set it, really, really low. Set it at, for instance, 0, and now you have the entire left tail, and you have it right up to 84, and it's done, and you find that there is a 78.81% chance of that happening. And we also have 100 bars. Wow, that looks quite a bit smoother still, doesn't it? What about 200 bars? By the time you get to 200 bars, if you really study closely, you can see where there's just like a little bit of squiggle, but mostly that looks like the smooth bell curve that we are familiar with and the accompanying CDF that's giving us our how value or how probability is accumulating as our random variable x gets larger. These are all doing the same thing, but they're doing it with a different number of categories. And this is interesting because very often we have an underlying data set that, say, is continuous in nature, in this case, normally distributed. But for whatever reason, we are using a histogram. We are classifying or categorizing in a certain number of bins. And we can see where the number of bins that we choose is, the more bins we choose, the more it's going to converge upon the true shape of the underlying distribution. The trick here, of course, is that you have to have enough data points. You can't have 200 different categories and, say 100 data points. Like, that's not going to be a good idea for you. So it has to be enough categories or enough data to justify your bin widths, as it were. Last thing to bring to your attention is Lines on Clay users, you can head on into the normal distribution tab of the sheet that we linked you, and you can see all of these side by side. So you get 30 bars, 50 bars, 100 bars, 200 bars, and you set the values yourself, and you can see the underlying distributions and the probability of falling within a given region, which, hint, hint, is going to be very helpful when you are doing the assignment problems that we have waiting for you.